All right, let's go ahead and jump back into the questions for the Introduction to Web Dev quiz number 3. We're starting off with this question here. Async await is a syntactical sugar for wrapping function returns in promises. A, true, or B, false? The answer to this is A, true. And this question features one of my favorite phrases in all of computer science, syntactical sugar. Oh man, that phrase is just like butter to my ears. Syntactical sugar, let me break it down for you, is just a way of making code easier to understand for humans, or in other words, sweeter, right? Just kind of like a cute little phrase people came up with. So async await is just a way of wrapping function returns and promises in a way that looks nicer to the eye when you're reading the code, right? So let's go over this code here. So we've got this async function say sup, and we're calling it down here, and we're storing that into the message variable. One thing to point out is anytime you see this async keyword in front of a function, what that means is this function is going to return a promise. It may look like it returns a string, right, sup plus the name, where the name is the parameter passed in, but since we have that async keyword, it's going to return a promise. If you were to do console.log say sup Olga, it wouldn't print out sup Olga as you might anticipate. It's going to print out the promise. And the reason why is we still need to await that promise. When you await the async function and you store that into a variable, then what happens when you print out the result of that variable is you get that hello Olga. So we could have written this in kind of a more nasty way with promises, but with async await, the reader and the writer of the code knows that there are promises being involved. They just don't have to, write out new promise. Async will do that for us. So kind of nifty. All right, next question. Await async is a way of making synchronous code behave asynchronously. A, true, or B, false? This is false. It's actually the other way around. So as mentioned in the last question, await async is for asynchronous. Always hard to pronounce those names for whatever reason. Asynchronous code. And when we use await async, we're actually forcing it to execute line by line. So let me kind of explain what I mean by that. So here we've got, on the example on the left, we've got a .then.catch structure. And what happens when we use the .then.catch structure is what's shown up above, where the first line of code is run, let value, blah, blah, blah. It's run, and then we don't even wait for it to finish. We move on to the next one, where we call this blah5 function, and then the next line of code is executed. It kind of goes line by line. Versus here, we can't run the second line of code until the first one has finished. So we're saying, when we put that await keyword, we say we want to wait until blah has finished executing before we are done with this line of code. So JavaScript kind of pauses, it waits it out. Once blah is done running, it's got the value set as value, it moves on to the next line, and then we await for blah to run. Same thing happens, and then the third function runs. So it's more synchronous this way, where as soon as the first event ends, the second one can start. As soon as the second one ends, the third one can start. And this is probably not a super accurate representation of what 1 through 3 looks like. We're probably going to start the second one here, the third one here, but the idea is that we still have some sort of overlap because we're not waiting for the .then.catch structure to finish up. we're just setting it off to the races and then moving on with the rest of the code. So this is kind of, you're comparing the pros and cons of await async versus the .then .cat structure, where await async, you want, let's say for example, let's say you have to get that value before you can move on to the next line of code. Await async is a good structure for that. If on the other hand you don't really care which order it goes in, or if you don't really care if the second line is run while the first one is still running, then .then that catches for you. Alright, next question. For error handling with async await, it is recommended that you use a try-catch block. A, true, B, false. The answer is true. So as I mentioned above, when we're calling await, we're waiting for whatever async function is to the right of it to finish running before we can move on to the next line of code. Let's say, for example, that somewhere within get value, we get an error, right? Not really important what it is, but we've got an error. So now the value of value is not defined. But you might notice in this next line of code, we're passing that value into this get another value function. All right, that's not really good, right? What if, and then to make matters even worse, what we're doing is we're not really getting any value here, probably. We're probably rejecting this function here. We're probably crashing something. But then we're placing it into, we're passing it as a parameter into another function, get some other value. So we probably, this some other value probably also is either, null, or this function is crashed, So when we're using await async, we really want to have that try catch, because if at any point within the curly braces of the try there's an error, we can run this error processing code. So we're not propagating this error and creating this really big dumpster fire of errors, and we don't assume that we're able to assume that we can get to this last line of code. And if we didn't have any errors here, then that means that some other value has some sort of valid variable inside of it. Alright, next question. For which of these scenarios can promises be useful? A, file I/O, B, database transactions, C, API requests, or D, all of these? The correct answer is D. Let's kind of talk through each of these. Promises, as you might recall, are good for when you need to wait for something and you're not quite sure if you're going to get a positive or negative response. So you might resolve the promise or you might reject it. And with each of these, there's a scenario in which you have a successful transaction, a successful file upload, a successful API request, or failures for all three of those. So, for example, let me just go through the fail cases of this. So let's say you're trying to look for some file.pdf on the user's computer, but they don't actually even have that resource, and they get like a 401. That would be a scenario in which a promise would be good, because then we can run whatever error handling code we have, right? For database transactions, let's say we're trying to insert something into a database, and I don't know, maybe the database got deleted or it no longer exists, and it fails, it bounces back. We can also have error handling code there as well. We can reject that promise. We can say to the user, oh, whatever, your attempt to like add a new user didn't work, right? And then let's say we have some API. This is the I found a cat API that, I don't know, I think it gives you like a random cat image. But let's say that like whoever owned the API just randomly decided to take the website down one day, and you get a 401 if you try to go to this website. That would be a really great use case for a promise, because if that happened, we could reject the promise. We could show some sort of error like, oops, we weren't able to load that cat image, or something like that. So when there's any sort of uncertainty, then you want to be using promises. And all three of these are good examples of